By now, you've learned one of the two ways to present raw or ungrouped data in a prettier and understandable way, which would otherwise make you pull your hair out. In this video, we're going to play around with a continuous frequency distribution. The first column of the continuous frequency distribution is in the form of groups having intervals. We can call them class intervals or simply classes. But hey, to get these intervals, we need to know a few things. First off, the range. It's the difference between the greatest and smallest observation, which is 6 in our case here. This range affects the number of groups, which are denoted by k. So basically, the number of groups could be more or less, depending upon the range of the observation. Lower the range, lesser the number of groups needed to represent the data, and vice versa. Now, the range and the number of groups k both decide the gap between each interval. This gap is formally called the size or height, denoted by h. This is the formula we can use to find out h, which clearly shows that h depends on the values of range and k. Now look, you see these two values that each interval has? Well, out of these two, the minimum value is called the lower limit and the maximum value is called the upper limit of each interval. And that's all for the basics. Let's go ahead and use all of this in a question. On the left here, we have the marks obtained by 40 students in a math test. Firstly, how do we figure out whether to convert this raw data in a discrete or continuous frequency distribution? Well, of course. Since the question mentioned class interval, it's evident that we'll go ahead with the continuous frequency distribution. Moving on. Since we're already given the range and the number of groups k meant for class size h, we'll go ahead and skip these steps. Let's speed things up and go right ahead to making the intervals. Now, we can either start with our minimum value of our data, which is 2, or with a 0, which is the nearest smallest integer. For our convenience, we'll take 0. Now, starting from the lower limit, 0, count all the way to a gap size of 10. We reach 9. Well, 0 to 9 becomes our first interval, having a class size of 10 in between. The second interval starts from the observation right after the first interval ends, which is from 10 and goes all the way to 19 after a gap size of 10 in between. You all can do the rest now, can't you? That's what I like to hear. But don't make more than 7 intervals. Our maximum observation 60 is covered in the 7th interval ending at 69. We can stop here. Now comes my favorite step, tallying the observations, which we learned how to do in the previous video. Now, what do we do after recording the tally marks? That's right, we count and record them in the frequency column. The sum of frequency confirms that the job is done right. How easy was that? I'd say a lot. But hey, there's one more method by which we can record the frequency distribution. Instead of tally marks, we can just note down all the observations lying within each interval. Like the observation between 0 to 9, which are 7 and 2, can be recorded here in order like this. The number of observations, which is 2 here, can then be noted down in this frequency column. Similarly, we'll write down the observations lying between 10 and 19, which are these 10 values. This makes the frequency of the second interval a 10, and so on. So, instead of tallies, we can also directly list down the observations. It's the frequency that matters in the end, after all. And that, students, is how you can convert a raw data into a continuous frequency distribution table using 2 different methods. Now, what if I told you there's more to a continuous frequency distribution? You heard it. But you'll have to come back for our next video to find out. I'll see you then.